All right. Great day to you. And we are on part 2 of the t-test lecture. And this is going to be how to use the t-table. So once you have t OBT or t obtained, and not every textbook lists it this way. We're just listing it this way in this class, and a couple other textbooks use this, but you may not see that. You may just see t. But here's the equation we just went through, and let's talk through what you do with that now that you got it. I believe the score was 1.67. I will have to take a look back to see if that is indeed the case. What was it? 1.62. Okay, let me write that down. All right. So back at it. So what this is, TOBT or T, we'll just call it T from here on out. What T is, it's a critical value. What else was a critical value? Well, a z-score was a critical value when we used the z-table. So you obtained the z and used the z-table to find out and convert it into a percentile. And so here you have another one, and this is t. And this works with the t-distribution. I will probably do another supplementary lecture on what distributions are. All right, so there we go. Almost there. All right, so the T, where you will see that is in tables, in articles, and you will see it in the written results of research articles. And here you will see it written as T equals 3.32. So someone, somewhere, did the calculations, or probably SPSS did it, and came out with 3.32 as the T value. And a couple other things, just really quickly to finish this up. Degrees of freedom, DF. So the formula for degrees of freedom for the T is the sample size plus of group 1 plus the sample size of group 2, subtract 2. So I know just by looking at this that the sample size was 48. And then here's your p-value. So again, p stands for probability of making a type 1 error. So p equals 0.0001 or 1 in 10,000, or a very, very small, very slight chance of making a type 1 error. Which again, a type 1 error is a false positive, where you say something's true, but it's not. All right, and we're going to determine whether how to use T to do that. So here's your T table. Now, the T table is based on the T distribution. The T distribution is mathematically derived. It's been mathematically derived for over about 100 years now, a little over. And so we've had this table for a long time. And these are the tables that were programmed into SPSS. So SPSS consults these tables. When you click to do a t-test, you consult these tables. It will just automatically consult them. And it will run your data and give you the actual T value. But for purposes of enlightenment and good education, it's important to know about these tables. So let's talk a little bit about what's in the table and how how it compares to the z distribution. So here it is. Okay, so the z distribution is a standard normal, and the t distribution also looks normal. It's a bell-shaped curve. Right here it is, the red. And so the more sample size you have, right around 30, that sort of seems to be the sweet spot. You get a very handsome looking bell-shaped curve. If it's smaller than 30, you get more of a lump. This would be called platykurtic as well, right? It's flat. The steepness, right, is called kurtosis. And so that's just to show that there are different types of distributions used. That's about all I'll say about that for now. But here's the t-table. Again, you have the factor across the top and down the side. So let's take a look at what's in the t-table. All right. So across the top here, you have the significance level. So this is your certainty. This is the certainty column. Down the side, you have degrees of freedom. In this case, we'll talk about this as sample size. Okay, for the t-test, degrees of freedom roughly is a measure of sample size. I'm leaving a lot out of that discussion. But for our purposes here, we just need to know that this number is calculated by the sample size of both groups, subtract 2. So if you have a sample of 20, 10 in each group, then you would use the row of 18. If you have 30, 15 in each group, you would use the sample or the degrees of freedom of 28. For t-tests, you may be asking, so for t-test, is it always n sub 1 plus n sub 2 subtract 2? And the answer is yes. You will always have that equation for t-test to determine the degrees of freedom. And that is one of those things that shows up on the licensing exam. It's trivia, but it's still used. All right, so down the side you have degrees of freedom. And you're going to use this just like you used the other table, where you find your column at the top. And in this case, we're going to use 0.05. So we set alpha at 0.05. That just means we're going to choose the significance level of 0.05. We set alpha at 0.05. That's how it's talked about. So you might be, standing in the lunch line at APU when you come back, and they say, oh, what alpha are you going to set? And you say, well, I'm going to set my alpha at 0.05. And they'll say, well, fantastic. I'm going to have the orange chicken. Let me tell you, this orange chicken, you wait till you get to campus. It's the absolute best, and I am longing for it now. Okay, that was a brief sidebar. So you will be setting alpha at 0.05. All right. For this particular study of these bogus numbers, we had a sample size of 10, so you subtract 2, you get 8. It's going to look different on your slides because I realized that I made the line in a different area, so don't let that confuse you. I've corrected it here. So you had a total of 10. We've been messing with 5 sets of numbers, or 5 numbers in each group. And so this is the row you're going to be looking at, and then you're going to be looking at this column. See, I didn't change it, so I need to change that at some point. So ignore this line, pay attention to this. So 8, and then you go down the column at 5%, and this is the critical value. critical value is a decision point. If your t value is higher than the critical value, then it says it's significant. And it says it over here. So the critical value for t with this group is 3.182. If t is larger than 3.182, which is not the case, I really need to redo this. Okay, I'm really messing you up here. Sorry about that. It's because I did the wrong line. In this case, if t is, we can substitute in here 2.306. Why is that? Because I made an error on the previous slide. Don't hold it against me. So 2.306 is the t-value that we're interested in. And that says you set alpha at 0.05 and your sample size was 10, subtract 2, you have 8, and there you have it. So if it's higher than this, it's significant at the 0.05 level. If it's lower than this, it's not significant. And that's all it does. If it's higher than this, you reject the null. If it's lower than this, you retain the null. If it's higher than this, you interpret the results as statistical and significant and real. And if it's not, you say you found nothing. If it's higher than this, the possibility of making a type 1 error is 0.05. If it's below this, you may be making a type 2 error because your sample size is too small. All right, so that's the t-table. Sorry about the error. I hope you'll forgive me for that. And that's all we have for using the t-table. And there you go.